Hello everyone, today we're taking a look at LeetCode problem number 454, which is 4-sum part 2. So you may have come across problems like 2-sum in the past, and the good news is that the key intuition from problems like 2-sum will be used in this problem as well. And if you don't know what that intuition is, don't worry, I'll be touching on that in just a minute. And it's very, very simple, and this question is really much simpler than it looks when you first try to take a crack at it. So let's try to understand what the problem is actually asking of us. The problem says that given 4 integer arrays, nums 1, 2, 3, and 4, all of length n, so they're all going to be the exact same length, return the number of tuples such that all of them are greater than or equal to 0 and less than n. So pretty normal. It's basically saying that if you've gotten a certain number of elements in the array, this is going to be 0, 1, 2, 3. This is always going to be less than 4, and it's going to be greater than or equal to 0 if the n equals 4. So that's all that's saying. It's fairly simple. So what else does the problem say? These indices must add up to 0. That's the other requirement. So usually there is a target provided in 2-sum or 3-sum problems. This one just doesn't have a dynamic target. It just has a target of 0. So that makes things a bit simpler. Let's look at the first example. So they gave us, again, 4 tiny arrays, this, and this, and the indices of 0, 0, 0, and 1 add up to 0. So 1 minus 2, which is minus 1. Again, minus 1 is minus 2. And then minus 2 plus 2 is 0. And they found another instance of this happening. So pretty simple. Second example is even simpler. They have 4 arrays. All of them are single digit. And they're all obviously adding up to 0 because they are just zeros. Now, the constraints, let's take a look at those. It's always a good idea to check those out. All the individual arrays are going to be the exact same length, so that's great news. Number of items could be from 1 all the way up to 200, and it could contain negative values. So now let's go back to what I'd mentioned earlier in the video, which is the main intuition. So the intuition from 2-sum problems, just to give you a little bit of a refresher, or if you're not familiar, just to kind of brief you on what you should know about problems like these. So if we're given an array, just a single array, and asked to find 2 digits that add up to a single number. So let's say in this case the array consists of 2, 3, 4, 5, right? Just 4 items, and we're looking for a specific target, which is 7. Now, the very naive approach and very complex approach in terms of time complexity would be to look at the first item in the array and then try to find every possible combination of that item and see if any of those add up. So in this case, we looked at this one, we looked at 4, we looked at 5, we're like, okay, great, we found a match. But if you give it some thought, you realize that the complexity of that is big O of n squared, with n being the number of items in this array. So if it's 4 items, we're easily looking at 4 squared, which is going to be 16, because that's 16 possible combinations of each number with another number. So then the main intuition and the main way to solve this problem is to use a hash table, because if in a hash table we can just throw these items in, so if we have 2, 3, 4, and 5 in a hash table, now when we go through these individual items, we're looking at 2. We know that in order to get to a target of 7, we're gonna need a 5. So we just simply go back to this hash table and we ask it, hey, is there a 5 in here? The hash table goes, oh yes there is, here you go. And we know that we found ourselves a match. All right, same thing with when we look at 3, we ask the hash table, is there a 4 in here? It says, yes sir, we found another match. All right, so that just really simplifies the entire complexity and brings it down to O of n. We're only just doing this operation for the number of individual items in the array. So This problem is a bit different though, because not only do we have 4 different arrays, the target stays the same. It's always 0. And you'll see why that leads to a bit of a simplification later on, which is going to help us out. So I remember thinking about this to myself and thinking that if the naive approach of having only one array and trying to find a target is n squared, because you're looking to find n times n combinations, with this it could actually get a lot worse, because now let's say we've got the same arrays as we have in this example. So we have 1 and 2, we have -2 and -1, and we also have -1 and 2 and 0 and 2. Now we know we're gonna have to touch all these items individually. There's no way around that. Now, how do I actually figure out what the best path is? Because I'm almost thinking about this like a path. So I could start here, and then I could go here, and then from here I could go here, and from this point maybe go down to here. Does that work? 1 -2 -1, and then again -2 0. No, that didn't work. So then I start again here, and then I go down here. Like, that is really starting to add up, and ultimately you realize this is actually fairly complex. This is big O of n to the power 4. So knowing that this can be up to 200 items, as we know from the constraints, that could be a really, really complex program. So is there a simpler way to do this? Like, how do we actually simplify this for ourselves? And the thought that I had that made me move forward in this function is, hey, I don't know how I do a 4-sum simply, but maybe I could just do a 2-sum twice. Like, could I do that? And the answer is yes, you can. And this is a little bit of how that would work. So I'm going to move this out of the way. Let's move this to the left and create some space in the middle. And the way that this is actually possible for us, and the way we can actually make it happen, is we simply create, instead of one hash table, we create 2 hash tables. So we'll have one on the left and one on the right. And what this hash table is responsible for is to store the sums of just these 2 arrays that are on top of each. So hash table number 1 is in charge of these 2 arrays, and hash table number 2 is in charge of these 2 arrays. And we know that within this there are O(n) squared sums, and same with this. Well, luckily, O(n) of 4 and O(n) squared plus O(n) squared, these are not really the same. This is actually much better. For example, if we're looking at, let's say, 3, because n to the power 4 in the case of 3 items would be 81, but n to the power of 2 times 2 would be, in the case of 3 again, 9 times 2, 18. So there's a pretty massive difference in these 2 ways to solve this problem. So how does this actually work? Within this hash table, what we do is we store a specific number of combinations. So 1 plus -2, that is -1. And the second is 1 minus 1. Okay, that's a 0. Now, what else do we have? We have 2 minus 2, so that is 0 again. So instead of adding another 0 to this hash table, what I'm actually going to do is I'll just go ahead and say 0 occurs twice. So let's start saving the number of instances, and by default this will be a 1. 0 occurs twice, and the last one is going to be 2 plus -1, which is basically 1. So 1 also appears just once. Let me change the color on that. So that's our first hash table. The second one, exact same approach. Let me get through this quicker. So -1 plus 0 is -1. And then -1 plus 2 is 1. 2 plus 0 is 2. And 2 plus 2 is 4. All of these are showing up just once. So we had no repeats. 1, 1, 1, and 1. Now, all we're doing is doing the exact same thing as we did before, but now with these two hash tables. So we look at every single value in hash table number 1, and we know that, hey, when we're looking at -1, in order for it to get to 0, we're gonna need a 1. So when we're at -1, we check, hey, does this other hash table have a 1? Great, yes it does. And this is where having stored the number of instances actually helps us, because in this case, 1 just appears once, so we change the number of results to 1, and we're gonna keep incrementing this counter as we go. When we're looking at 0, so in order for 0 to work out, we need another 0. Unfortunately, there's no other 0 in this. Then we look at 1. For 1 to work out, we're going to need a -1. Do we have a -1? Yes, we do. So then we have a 2. Now, the only other instance, only other possibility would be if -1 actually appeared twice. So let's say, for example, one of these numbers, instead of it being, it was, I can't think of a good example, but let's say this was, instead of 2 and 0, it was a -3. So 2 and -3 is -1. Now, if that was the case, in addition to -1 and 0, this would have been 2 instances of -1. And instead of adding just 1 more here, we would have added 2 more, because 1 plus -1 is 0, -1 appears twice. We have 3 possible combinations, and that would have been the result. So, in summary, the way that we're solving this problem is we are effectively doing a 2-sum, but we're doing it twice. So we find these results, we find these results, and then we try to make a match happen. And in this case, it was just 2, which is the same as the example provided above. And that's it. Now let's go ahead and jump into the coding. What I'm going to do is I'm going to start off by initializing a variable called length. I feel like I'm going to be referring to the length on a number of different occasions when I go through my loops. So I just want to start off by saying length is going to be nums1.length. So I'm going to come back to this variable in a second. And let's go ahead and initialize those 2 hash tables that we're going to be using. So let first 2, which is the first 2 arrays, the hash table containing the first 2 arrays, equal new map, and let second 2 equal new map as well. Now, what we're going to be doing is what we just described in the drawing as going through 2 arrays at a time and storing their sums and the number of times those sums appear into this hash table. So I know that's going to happen twice, so why not just write a function for it and then call it twice with the right parameters containing those 2 arrays and the appropriate hash table to which the function needs to add the values. Let's go ahead and write that. So I'll go ahead and call that function add to map, and my parameters will be nums a. So the first the first array of values, nums b, and the map to which it's going to get stored. And for now, we're going to need a for loop. So let's go ahead, and this is the part where we use that variable that we've stored earlier. Let I equal 0, just to save us some characters, and I is less than length. Let's create some spacing, make this a little bit more legible, and I++. So that will be our first kind of layer of the for loop. The second one is going to be for let j equals 0. I'll add some space here for the sake of consistency. And j is less than length, exact same, and j++. At this point, I'm going to describe a new variable that basically is a bit of a checker for me to see if this value that I'm about to add already exists in the hash table. So we'll just do map.get, so map being the specific map that's been passed to this function, nums a, I plus nums b, j. So we know this is going to be on to the power of 2. That's okay. We're just going to do that twice. So we know that's not that bad. We have a bit of a nested loop here, but it's been accounted for. Map.set, and what we're setting here is nums a I plus nums b j, and this is where we use the getter. So if getter already exists, like there is a value that's already stored, then all we'll do is we're just going to go ahead and increment that value. So if a 0 is already stored, you know, tell the map that it appears twice and not just once. Otherwise, just go ahead and assign it a 1. 0 appears once, for example. We will call this function twice. So let's call it for the first 2 arrays. So nums1, nums2, and we need these added to the first 2 map. And we'll call it again, nums3, nums4, and we want this added to the second 2 map. So all of the sums have been added, so have been their instances, the number of times they appear. Now, we're going to need a return count. Like this is the count that we're going to return at the end of the function, so I'm just going to go ahead and start that at 0. And at this point, we're going to go through each and every entry of first 2 to find and check for any matches. So go through every entry of first 2, the hash map we have at the top, and report any matches, seeing as we need to find sums that add up to 0. So first 2 dot for each, use a for each, and we're going to need the values and the keys. Start narrow function, let getter, again, I just like the word getter, second 2 dot get. So now based on the value that we're looking at right now for first 2, look at the second 2 dot get key times -1. Basically, if we're at a 2, like this is the main kind of helper of having 0 as a target. If the sum that we're looking at in first 2 is a 2, we know we're going to need a -2 in the other one for it to add up to 0, right? Nothing else. There's really no advanced math meter here. And if we don't have the exact opposite of it, like if we have a -2, then we're going to need a +2, then that sum of 0 is not going to happen. So that's what getter is going to check for. And if getter exists, go ahead and increment return count by getter times the value. So this is necessary because if we have 2 zeros, for example, in second 2, and we were sitting on, you know, we had a 0 in first 2 as well. Now we know that's 2 possible matches and not just 1. So we're going to add 2 instead of 1. Otherwise, the value is always going to be just 1, so we'll increment by 1 if it's just 1 instance. And in the end, we're going to return the return count. So that's basically it for the code. We'll go ahead and submit that. And it looks like I made a mistake. I made a bit of a typo here. And let's go ahead and submit that now. There we go. So fairly efficient function, and that's it for this problem. I hope you guys liked the video, and be sure to subscribe for similar content like this. I'll be solving more LeetCode problems. And see you in the next one. Take care.